Okay, so now we are going to take a look at a fairly serious problem. In this case, a cantilever beam problem. And in this case, the first step is to always choose your coordinate system. Choose your coordinate system from the free end, not from the built-in end. It will make your life a lot easier. So remember this always. Okay, this is a very good trick. It's a very useful one. The next thing to do is, if you're going to do polynomials, it is better, you cannot satisfy all the boundary conditions. The only way to satisfy all the boundary conditions is to use infinite series. That is, P not P3, P4, P5, P infinity. Basically, every order polynomial you have to do. But if you allow some of the boundary conditions to be weak, basically this side and that side weak, this side strong, then you can do polynomials. That's the idea. Okay, so off we go. And I'm not going to look at the details because you can always read it in the notes. I just want to show you boundary condition on the top and bottom or polynomials. Boundary condition on the lateral side, you have to do only one lateral side, not both of them. And you'll have to answer why that is. Okay. So the one lateral side, we have force is known, moment is 0. Okay. The question is, now we are going to try a polynomial solution. What order polynomial to choose? Okay, the answer to that comes from strength of materials. So if you looked at the stress sigma, you know it is my over I, no? And in this particular cantilever beam case, so if you look at a cantilever beam and if you look at this point, m is f times x. So your sigma xx will look like fxy over I. But this is a comma yy. So you need something that looks like c times xy cube. If you integrate it twice, you will get some constant times xy cube. We will worry about all the constants and other things, but what we want to do is get an estimate for the order. So if you do that, you will immediately get sigma xx equal to 6c1y. So let's try this as my area stress function. You will immediately see that first of all del square of del squared A will be 0. So this is our trial. Del square of del squared A will be 0. So sigma xx will be 6 times, sigma xy will be minus 3, blah blah blah, sigma yy is 0. Okay, the problem is it will not satisfy the strong boundary conditions. So what you do is you need to eliminate strong boundary conditions because of the shear stresses. So you add a term that looks like that. So you will get axy is c1xy cubed plus c2xy. Then everything will be satisfied. Things are very nice. Off you go. You can use the strong BCs and you can find the solution. How about that? Okay, you can look at the details, but I want you to get the idea. You guess the stresses by looking at strength of materials, rough idea, and then you can actually figure this out. Okay, the problem with this is it's very difficult to do for something other than trivial problems. So how do you do for something more that's fancier? I will show you in a second.